Okay, it's going.
Okay.
Sweet.
Alright, start this thing.
Okay.
Okay. Should have opened this already. That applet thing.
To find the combined area under the standard normal curve that is to the right of z equals 1.358.
Sorry, I'm pulling up the applet thing.
Yeah, so I should have left it open from earlier, but didn't. I know it's just to the right, I think it said, right?
And to the left of z equals negative 1.358.
Oh, to the right and left?
Yes.
Okay. I got 0.175.
Yep. That's what I got too.
Okay.
Hold on, I think I did mine wrong. I got something different. Oh, yep. I did. Okay.
Cool.
Alright, yes.
The United States Coast Guard assumes that the mean weight of passengers in commercial boats.
Okay, so basically we just have to find the z-score and plug it in.
Mm-hmm.
Okay.
The sample angle is determined. Find the probability. That's extreme or extreme means. Interesting values. Okay.
Wait a sec. How do you find the z-score without a...
Without what?
You have the mean and the standard deviation, but you don't have the weight.
It's the mean divided by the standard deviation.
Yeah. Right? I also... Because we have that first original, so why don't you just take the new mean minus that old one?
No, because it says find the probability that a random sample of passengers will have a weight that is as extreme or more extreme than was observed in this sample. Well, I guess it would be actually.
I think it is. Because I'm like, I don't think I...
Okay. So it'd be 177.6 minus the mean.
Yeah, I'm gonna go
Here.
see if I can find that little...
Because finding the z-score, like from what it says here, is you have a number and then you subtract it from the deviation divided by... no, you subtract it from the
original mean.
mean and then divide it by the standard deviation.
Yeah.
Okay.
because I know on that answer key there was another formula. I'm gonna see if I can pull it up really quick.
I don't know why, but my brain's not working right now.
It's okay. I don't think anyone's is right now. Yeah, mine's not.
Deviation. Man.
Okay. Yeah, so it's value minus mean divided by the standard deviation. So, yeah, I'm pretty sure it's just what we did.
Okay, so then it would be the 177.6 minus the 185? Or would we put the 185 first? Which one are we using for our value?
I would use the 177 as the new value. To me, that makes the most sense.
Yeah.
Wait a second.
Ugh.
This isn't supposed to be negative, right?
No. That's a Z. I think that's a Z score.
The z-score can be negative.
Yeah, it can.
So, looking on this formula, it says the value minus the mean divided by the standard deviation, which is divided by the square root of the sample, like the number of samples. So I feel like we need to do one more step in here. What is square root of 48?
So divided by the standard deviation divided by...
By the square root of n, which is your sample.
Wait, what are we doing now?
Well, if you look at on the answer key for the preparation assignment, number 2, it shows you how to get the z-score for this one.
I don't know if we're supposed to do that because it just says a random sample.
But wouldn't that be including your random sample so you have an accurate?
We don't know how many's in our sample, though.
Yeah.
Yeah, we do.
Well, we've got
48.
the 48.
Well, we have the 48, but the random sample doesn't have a specific number.
I guess that's not making sense.
Either over below the mean.
Wait a sec.
Although, you might be right, because if we're
wouldn't it be
thinking
100%?
Huh?
Wouldn't it be like 100% probability?
That they'll have a
Oh.
weight that is as extreme or more extreme?
Yeah.
No, because
No.
Because it says as extreme or more extreme means that we are not only interested in values that are lower than the ones we observed, but also values that are as far away from the mean as ours in the positive direction.
As extreme. More extreme.
I feel like the extreme ones are ones that are like further out of the bell curve.
That's kind of what I was thinking. And I was thinking about the 68 95, 98 rule too.
Yeah.
Because 177 is within that one standard deviation, so it would be at least the 68, but seeing as how it's like halfway, I would think it'd be right around the 77 to 78 mark, which is what I'm getting.
So what did you get for your answer, Lindsay?
I got 0.782.
Let me see.
Okay, and how did you find that?
Yeah, how did you do
Something
that?
different.
Okay, so I took the 177.6, I subtracted the 185, and I divided it by the 26 point whatever it was, 0.7. And I used that as the z-score, and then I took the two, which were the extremes and not the mean portion.
Oh, okay, that makes a lot of sense now.
Is that what you guys were thinking, or what did you get?
I did it a little different, but I think the way you did it is right.
I mean, that's what's making sense to me at the moment.
What the heck?
What are you guys thinking?
I don't really know, to be honest.
The way I did it is wrong. So, okay, so you took the standard deviation, then which equation did you plug that into?
It was z equals the value minus the mean over the standard deviation.
Okay.
Let's move on to the next questions, I think, and then come back to this one.
Okay.
Okay. I'm just going to put this in case we need to come back to it.
Okay.
Okay.
Which of the following will have a smaller standard deviation if none of them is randomly drawn from a population?
Wouldn't it be the sample means?
Yeah.
I think
what
so, yeah.
That makes most sense, because the means are going to be a lot closer.
Yeah, and individual observations are always a little sketchy, and then... Although I guess it could be the cannot be determined, because technically the means doesn't, I don't know, start showing like an accurate pattern with numbers that low. But I do think that is the closest answer.
Yeah, I think the sample means is okay. Which of the following results implies that the spread in X decreases as the sample size increases?
Doesn't law of large numbers deal with sample size? Or is this the central limit theorem?
I think it's the law of large numbers.
I think so too.
It is, yeah.
Okay.
Yeah.
Present quantitative portion of the jury. 8.8. Use this information to add. Questions 7 through 10. 60 quantitative portion of the jury.
I got 1.05.
1 sec.
Oh, 0.045 because it's 3 decimals.
Hey, what did you get again?
1.045.
Yeah. That's what I got too.
Okay.
Yep.
Cool.
60.
Alright, what is the probability that randomly success?
Got 0.148.
For 8, you got 0.148?
Score above 160, right?
Yeah.
We just calculated out the z-score, so just plug it in.
Yeah, 0.148. I just had to plug it in. The z-score is 1.045 for number 9.
I'm almost there.
That's what I got anyways.
What did you get?
Well, the sample mean of the student scores is 160.
Mm-hmm.
Mm-hmm. So it's the same thing we did earlier, right?
Yeah.
So it'd just be that
It
0.
should just be the same. I don't know if there's a different process that we're supposed to do to get that.
I don't feel like it would be. It's the same thing.
Let me see. Wait,
Yeah, I got the same answer.
some scores.
Okay.
Okay, so are we all on 10?
Mm-hmm.
Yeah.
Okay.
So for students,
Wouldn't it be 0.148?
Yeah, and then you want to add the 0 on the end.
I just think it's almost a little bit silly that they're the same answers.
I almost feel like he's just trying to trick us.
Yeah.
Like earlier in the semester, I mean, did it before. It'd be approximately normal, right?
I think so, yeah.
Because we have 81 students in the sample.
Yeah, so I think it's big enough that it'll be good.
It's over 30, so yeah.
What does the mean of the distribution of the sample means? I wish they'd be consistent about how many decimals we had to put on this.
Mm-hmm.
It's kind of obnoxious.
What was
Yeah.
number 11? Sorry, it'd be left skewed, right?
It would be approximately normal.
Oh, never mind.
Yeah.
It's 81. Sorry, I'm a little bit
Yeah.
behind. I was looking
No,
for
you're good.
the anything more about question number 5.
Gotcha.
But
You know how to do 12? Kind of
what's
confused.
the mean of the distribution? Oh, the mean of the distribution of the sample means.
What's the mean?
Is it just 3.5?
Yeah, the mean is the same.
I mean,
The standard deviation changes.
so 12 is just 3.5, right?
Yeah, the mean the mean stays the same.
What is standard deviation? Variable to me.
And the standard deviation changes. It would be
What does
the standard deviation divided by the square root of the number of in the sample.
So
Okay.
0.7 divided by 9.
Yes.
Okay, so
it's
0.07.
0.078.
zero? Yeah.
0.078.
Alright. What is the probability that the mean of the GPA? So it'll be students will be less than 3.3.
Less than 3.3.
So negative 0.2.
Where are you getting the negative 0.2 from?
It'd be that 3.3 minus 3.5 divided by the 0.078, and then you have your z-score.
And what did you get for the z-score?
Negative 2.56 something, and I just clicked off of it. Shoot.
4?
Yeah, it's
Yeah.
25641.
5641. Yeah.
Yeah, how many do we need for this one?
3 decimals.
Okay.
That the mean GPA will be less than 3.3.
So it's just that left side I got. Wow, that's small.
Holy cow.
So 0.0052.
0.001.
0.001.
No, it'd be 0.005.
Yeah.
Yeah,
1, 2, 3.
Zero
Yeah.
point.
0.05.
that's 3. Yep.
Okay.
I'm just crazy.
2 zeros and a 5. We got it. Okay.
Probability that the mean
Will be greater than 3.3. Almost all of them, apparently. 0.995.
Yep.
Okay, everyone feel good about those ones?
I feel good.
Yeah.
Okay, let's go back to number 5 first. I was just
Oh, what
wondering
did we get for 9? I didn't type that in, and I.
1.045.
Okay. Oh. Okay, yeah. Okay, so we wanted to go back to 4 or 5?
5. I was just wondering if you had any other thoughts on that.
Let me just go look at something really quick.
Randomly drawn from a population. Nice.
I think we're right.
I think so too.
Yeah.
I'm pretty sure it's that one. If not, you can
But-
all blame me.
Okay, and what did we want to do about 4?
Well, what if it's like all the same number?
What?
On number 5? Like if 9 observations are all the same, then
It would be equal, but that's not usually the case.
Yeah, I feel like that's very weird.
I know, but yeah, that's.
I know you're just trying to think about all the
Just-
possibilities.
Yeah, I'm trying to think of the professor because
Good
this is a math class, so
True.
never know. But from, I'd say 99.9%, the sample means are going to be smaller than the actual observations.
I think so.
Yeah.
All right, number 4. Goodness gracious.
I think it is the first one because it just makes sense with the whole 68, 90, and 599 rule. I do think it's 0.782.
Hmm.
Oh, no. Ah, shoot. Hold on.
Okay, yeah, I'm getting the same thing.
I don't know. I don't know why it's throwing me off, but it is. There's too many numbers involved.
Yeah, word problems are not my favorite.
So you said 0.782?
Yeah.
Mm-hmm.
Okay.
The
We'll go
only
with
thing
that.
that throws me off is that they give us the number of passengers in that sample. It's the only thing.
Yeah,
says
this is all very
either-
strange.
It just says either above or below the mean than was observed in this sample. So if it's either above or below, then that's like 100% chance. I don't know. It's just weird wording.
Yeah.
Yeah. What do you want to do about it?
I can't think of a different way to do this, I guess, or like a way to think around it.
Yeah, I
And
just
so-
think the wording's super weird.
Yeah. Yeah, this is not my favorite.
Because it could easily just be 100% because it says either above or below the mean, which is all of it.
I just feel like he wouldn't give us that kind of a problem on something like this.
I know.
Yeah.
I'm not sure. But I guess we'll just stick
I
to
think
it and see what happens.
Okay.
Yeah. Okay. So
Anything else we wanted to go over?
I think that's it.
I can't think of anything.
Okay.
Okay.
Well, all right. Time to submit.
Nothing. 4's wrong.
Yeah.
Yep. And so is 9 and 10.
Yeah.
Shocker.
Alright, so what did we do with that then?
I have no idea on 9 and 10.
I have no idea because it was the same thing. I got the exact same thing.
Oh my god.
Oh, jeez. I see it. Do you guys see it?
Yeah, the definition right underneath it.
Yeah. Mm.
That wasn't there before, right? That just showed up once we submitted it?
Yeah,
Okay, good.
I totally spaced that.
Okay.
Yep, same here. But now we know, right?
Yeah.
I guess.
Yeah, it kind of hurts, though.
Yeah.
Oh, it hurts. Jeez, okay.
Okay, what was number 4? Does it explain?
No.
Of course not.
Of course not. I still think it probably has to do with it gave us the number of random sample.
I think we had to put in the randomly selected value formula into there too.
Mm-hmm.
Except we don't know how many, unless we were supposed to use the 48.
Well, that's how many
Probably.
passengers they did. I'm not
Yeah.
sure of that. Oh well, now we know. That's all I'm
Okay.
coming to.
Alright.
Well, better luck next time.
Yep. Oh, and yeah, make sure to post the thing tonight.
Yeah.
Thanks.
Yep. We'll do. Okay.
Well,
See you
now we
guys.
know.
See you
Yep.
Tuesday.
See you later, guys
Bye.
or girls.
Thanks.